You're welcome back to the first example under this particular topic, indices. And the example says simplify the following. Simplify the following. Now you can see that we have like 1, 2, 3, 4, 5. We have like 5 questions here to simplify. Now the first question says 2 raised to the power of 2 multiplied by 2 to the power of 4. Now, how are we going to solve something like this now? So we have to use one of our laws. And the first law says that when you have the same base number here, and they have different powers, and they are multiplying each other, then you should add the power. We are going to have 2 raised to the power 2 plus 4. Since we have this and this equal, so we are going to have the power. And what we have there is 2 raised to the power 6. And 2 to the power of 6 can also be written as 64. Now, if we were told to leave our answer in index form, we'll just stop it here and then. But since you didn't tell us, then you just simplify it. You have to get to the last bus stop before you start. Now, quickly, let us look at the second question. It doesn't matter either they put number here or they put alphabet here. You will see that the second example here is an alphabet, x raised to the power 5 multiplied by x raised to the power minus 3. And what we're going to do here is we say x raised to the power 5 plus minus 3 here. Don't forget, we have minus 3 here. That is the way we're going to do it now, because the law says when you are multiplying them like this and they have the same base number, add their powers. So, and what you are going to do here is you're going to multiply this plus and minus together, because when plus and minus comes together, minus takes the power. And then plus times minus is minus. So we have x raised to the power 5 minus 3. X raised to the power 5 minus 3, and then that gives us what? X squared, because 5 minus 3 is 2. That is x squared. Now let's look at the third question here that says 2 to the power of 8 divided by 2 to the power of 2. 2 raised to the power of 8 divided by 2 raised to the power of 2. Now don't forget our laws. This one is the second law because we have division here, even though we have the same base number. So what we are going to do is 2 as 8 minus 2. And now 8 minus 2 will be 2 raised to the power 6. And 2 raised to the power 6 is equal to 64. Now let us look at the fourth example. Like I said at that time, in one of the laws, we were made to know that any number raised to power 0 is 1 or letter. So 11 raised to power 0 is just 1. So we don't need to labor much on that. Now let us look at the fifth example. We have like a combination of rules here. So the first one here, now we have numerator and we have denominator. So the first thing we need to do is we need to solve the numerator first, which is 2 raised to the power of 4 multiplied by 2 raised to the power of 2. So what we are going to do there is 2, since we are multiplying, you see 4 plus 2 over 2 to the power of 3. We have 2 raised to the power of 3, which is equals to 4 plus 2 is 6. We have 2 raised to the power 6 over 2 raised to the power 3. Now, if you look at this particular one, what this one is saying is 2 to the power of 6 divided by 2 to the power of 3. It's something like this. It's something like this. So if you like, you can write it like this, or if you like, it can take this form. Once this particular thing here is there, it means division sign. So, and then when we are dividing, what do we do to the power? When we have the same base number, we subtract their powers. And so what we have now is just 2. This one will come first because it's the numerator. 6 minus 3. And then what do we have there? We have 2 raised to the power 3 because 6 minus 3 is 3. And what is 2 raised to the power 3? It means 2 in 3 places. You are going to multiply. That's 2 times 2, 4. 4 times 2, 8. So the answer to B is equals to 8. You are welcome back to another example under the same topic, indices. Now, the example says we should simplify the following. Now we have like 2 questions here to be simplified. Now, the first question says 10 raised to the power of minus 6, put parentheses, that is bracket, raised to the power of 1 over 2. One of our laws says that when you have a base number like this and they have power and then another power side, the law says that we should multiply the 2 powers together before we proceed. And what we are going to say is 10 minus 6 multiplied by 1 over 2, minus 1 by 2. And now what are we going to do here? This is 2 here 1, 2 here 3. So what do we have now? We have 10 raised to the power minus times minus, that is plus. Plus 3 times 1, that is 3. So at this level here now, if I like, I can put that plus 3 there. If I like, I can just like 3. So I can say the same thing as 10 raised to the power 3. And 10 raised to the power 3, 10 raised to the power 3 means what? We are multiplying 10 by itself in 3 places. That is 10 times 10 times 10. And 10 raised to the power 3 means 1,000. And that is the answer to the first question. Now let us look at the second question here. The second question says 0.0001, everything raised to the power of 1 over 2. Everything raised to the power of 1 over 2. So what we are going to do there is the first thing, like I said the other time, is remove the minus. When you remove the minus, it turns to 1 over 0.0001. Everything raised to the power 1 over 2 now. We have removed the minus, that is why we have 1 over. So minus is no longer there. So what are we going to do here? So let us try to change this particular thing here, this decimal number here, to fraction. So we have 1 over this one. When you try to change this number here now, we say 1 over, because the only number that we have here is just 1 over. Decimal point to turn to 1. We count 1, 2, 3, 4. Put 4 zeros. So we now say everything is our 1 over 2. So now, the next thing that I want to do is we write our 1 here over this thing here, 1 over 2. One of our laws says that when we have something like this now, it automatically turns to root. That is, this one will be square root. If it is 3, that will be here, it will be cube root. If it is 4, it will be 4th root, and so on and so forth. So now, what this one will turn to is, we'll have something like this, 1 over 10,000. So 1 is still here, it's not under the square root. Now we can break it now and say square root of 1 is 1 over. Don't forget that this one is a single entity on its own, so you're not going to break it together. I'll separate them. Now, square root of 10,000 is 100. So what we are going to do here is we say this 1 divided by 1 over 100. That 1 divided by 1 over 100, and now we need to change this division to multiplication and say 1 times. Now flip this one over. Once you are changing this division, this one, it will affect this number that the denominator will go up and the numerator will come down. So we have 100 over 1. And what do we have there? So 1 multiplied by 100 by 1 is what? 100. So our final answer here, answer to this particular question is 100. another example that is different from those ones that we have been solving before, but we are going to use the same approach, the same laws that we have been applying to other ones. That's what we are going to apply to this particular one. The person says we should simplify 25 to the power raised to the power of 3 over 2 multiplied by 4 raised to the power of 1 over 2 divided by 9 raised to the power of 1 minus 1 over 2. Now what we're going to do here is, let us look at this particular question here. What can we do to this power? There's a particular law that says we'll write this like this, because this one will take the square root 25 everything 3. I think this particular one should be a 7th law from the previous tutorial, multiplied by, even this particular one now will have square root of 4, because 2 is here, it will be square root. I told us the other time that if the denominator is 3, it will be cube root. If it's 4, it will be 4th root. Anytime you have something like this, that's where you are going to write it. And since we have it like this too now, 3, that's why we have 3 outside. And then we have 1 over 2, 1 over 8 times 3. So 1 over 2 is what is causing this square root to be there. Now, over 9. 9 over, this 9 over, write this power 1 over minus 1 over 2. We are going to remove that minus. Minus will turn to 9 this power. Now, what do we have here? Square root of 25 is 5. So we write 5 raised to the power of 3 multiplied by square root of 4. It is 2. Everything divided by 1 over. Now this one now we can take the square root of 9 now, because that's what we have. So now from this level now, what do we have? 5 raised to the power 3. 5 raised to the power 3 is 125. That is 5 multiplied by 5 multiplied by 5. That is 125 multiplied by 2 over 1 over square root of 9 is 3. So what are we going to do to that? We have this one, 125 multiplied by 2, which will be 250. This line is divided by 1 over 3. I've not done anything. I'm just trying to make this expression here linear. 125 times 2 is 250 divided by this line means division over 1 over 3. And now I told us we are going to change this sign to multiplication. So we have 250 multiplied by 3 over 1. This one is over 1, 2. And then 250 multiplied by 3. We should have something like 750 over 1 multiplied by 1, 1. So our total, our final answer, which will be equal to 750. So when you simplify an expression like this, or a question like this, this is the answer you're going to get. Thank you. Another example on indices. Here on the board we have like 2 different questions. We are going to be solving now using our laws. Now if you look at the first one, the first question says we should simplify 3x everything raised to the power of 2 multiplied by 2x everything raised to the power of 2. Now, what are we going to do to this? Now, when you have an alphanumeric like this and everything is encapsulated inside the bracket, and then we put a power there, everything is enclosed like this and they put a power there. What he's trying to say is the 3, you are going to give each one of them this power. 3 is going to take 2 and x also is going to take 2. That's what it means. So if you like, you can put multiply by here. This one times this one, they are going to do the same thing. 2 is going to take this 2, multiplied by x also is going to take this 2. And what do we have here? 3 raised to the power 2 is 9, multiplied by x squared, multiplied by 4x squared. Now, what are we going to do to this now? Since we have number here, we can bring the number together and say 9 multiplied by 4 multiplied by x raised to the power 2 multiplied by x raised to the power 2. Now, what are we going to do here? 9 multiplied by 4 is 36 times. Now, since we have x here, raised to the power 2 multiplied by x raised to the power 2, so we are going to apply the first law of indices. Let's say 2 plus 2. That's the first law of indices, because since the two already are multiplying and then we have the same base number, let us find their power. And what do we have here? 36 x raised to the power 4. So the answer to this, to the first question, is 36 x raised to the power 4. And that is the answer to this particular question. Let us look at the second one. The second one now does not have a power, it's only the hex there that's having a power of 1 over 2, and then it's only the hex that is having this power. So let us break them. This is, we have 4 multiplied by x raised to the power 1 over 2. That's what it means. When you multiply this one, you're going to get this one back. Multiplied by 8 times x raised to the power 3 over 2. So what do we have here? Let us take number and number together. That is 4 multiplied by 8 multiplied by x raised to the power 1 over 2 multiplied by x 3 over 2. So you can see what we have there now. Just try to collect like times, and then what do we have? 4 multiplied by 8 is 32 times. Now since we have the same base number, I just add the power. So we have x 1 over 2 plus 3 over 2. Now, we have to add these two fractions together, and then the LCM of these two fractions will be 2. How many 2 can we get in 2? That is just 1 times this 1 is 1 plus, how many 2 can we get in 2? That's 1 times 3. So what we have now is we have 32 x raised to the power. We are going to add this one together, and that is 4 over 2. 4 over 2. And 4 over 2 is 2. So our final answer will be 32 x raised to the power 4 divided by 2 is equals to 2. This one is 4 over 2. So and this is our final answer to this particular